teach you a little bit about Excel, I thought it made a little bit more sense to deal with some real data together rather than try to show it in a PowerPoint. So I've loaded up here some data that I generated during grad school. Notice that it's not processed at all yet, so we're going to do that together. One of the first things that I want to do is be able to read the contents of entire cells, and I can do that by moving my cursor between two columns or two rows. In this case, I want to expand the column width, and I can just double click on that section and it will expand automatically to fill. Of course, I can always click and drag as well, and it'll expand to fill that way. But that gives me the space to see what I need to see. Now that I've got things expanded, I want to give some headings so I have some idea of what data we're working with. And frankly, so you do too. So I'm going to highlight this column. I'm going to right click and say Insert. That allows me to insert a heading column. It's really important to label our work in Excel so we can track back to what we've done before. So on this column, I'm going to label, this is the sample ID. Now that could easily get lost in the rest of the labels there, so I'm going to hit Control B, or I could highlight up here with the bold indicator so that we have a bold heading to separate it from the rest of the text. Likewise, I know that this is our absorbance at 652 nanometers, so I'm going to label as such, and this is our absorbance at 800 nanometers. Whoop. I want both of those bold as well, so I'm going to highlight both of those cells and then hit Control B. Okay, now that I've got those highlighted, we have some data, but it doesn't actually do us a whole lot of good yet. We actually took both of these absorbances because there's a lot of drift in this instrument that we got the data from. And so the absorbance at 800 essentially measures the baseline, and the absorbance at 652 is what we really need, but we need to subtract the two in order to get any meaningful data. So I'm going to again label the top of the column. It's going to be 652 minus 800. That's the descriptor for that data. And now I'm going to take this cell. I'm going to click in this cell right here. And I'm going to hit the equal button. The equal button indicates that we're going to start a formula, and then we can define things much like we would in algebra with each variable. So I'm going to say equal, and then I'm going to click on this cell. Now notice up here, this is called the formula bar, it says equal B2. That's the label for this individual cell that we've selected. Now it's saying that whatever is in B2 is going to be the result of that cell. Now I'm going to change that formula so it's equals B2 minus, so I'm going to subtract out C2, the absorbance at 800. Now that seems like not such a big deal, except that after I have this and I hit enter to complete the formula, it automatically completes that calculation. Not only that, but if I click in the bottom right of this corner of this cell, I can actually drag it all the way down and make the same calculation over and over and over again with very little difficulty. So now notice I've generated an entire column of 652 minus 800 nanometer results, and it took me almost no time at all. Now that's great if I want just these two samples. If I had taken a separate blank, I could label a blank cell over here, and I could say I actually want to subtract out the blank as well. So maybe the blank had 0.003 nanometers, and I want that subtracted from every one of these cells. Okay, so instead I'm going to say B2 minus C2 minus this blank, so M2. Okay, so that works fine for this cell, but notice the rest of the cells, when I drag down like this, are going to continue on. M2, M3, M3 of course has nothing, M4, M5, and so we have a problem. And so to fix that, we're going to use what's called an absolute reference. So an absolute reference is when we take a cell and we put a $ in front of either the cell letter or the cell number or both, and that essentially causes that cell value to be fixed no matter where we drag everything else. So now we've got this as an absolute reference, and that blank will always be in the same place. So notice I drag down again, and notice every one of these is subtracting out that blank value. Of course, there was no actual blank value, and so I'm going to reset this to 0 so they all have the original readings. Okay, so that gives us a little bit of idea of how we can write formulas. We can click in the cell and we can edit the formulas in the formula bar up here. Also tells us a little bit about how we should label our Excel spreadsheets, about how we can format in very simple ways. There are a few other things that are really important to know. So right here, we've got a couple of cells that are labeled as 0.5 UM, micromolar, UO2. And of course, this 2 is supposed to be a subscript. It's difficult to change the font in Excel. Unlike many of our other Microsoft Office varieties, we don't see a subscript label up here. So if we want to get to that subscript, we have to right-click and say Format Cells, and we actually have to click Subscript there. So notice I can get the UO2 as a chemical formula. Now, typically I ignore this, but if you do need to get something more formal, you can actually go through and notice you have to highlight only the 2 that you want, format, and then click the subscript. So you can very quickly see why that's a problem. Another thing that you can do is you can hit Control-Shift. Nope, that only works in PowerPoint, sorry. Let's see. Now, we did a fairly simple calculation here. Of course, when we have a more complicated calculation, it starts to get a little bit more difficult to keep track of in the formula bar. So we have 2 options. One is to use parentheses, try to make sure things are in the right order of operations, and just pay very close attention. The other thing you can do is make a separate set of cells. So we could say 652 minus 800, minus 800 minus blank. And so instead of doing the minus blank here, so we can get rid of that minus M2, we can drag it down so everything gets rid of that minus M2. And then we can go and say, okay, I'm going to take these 2, or this value, which is already 652 minus 800, and then subtract the absolute reference. And that would work just as well. Again, that's really just to illustrate what we'd do if we had a blank. But again, we don't actually have a blank value here. And so I'm going to delete this data. Now, I can delete all the data by highlighting it like this and then hitting delete. That's fairly straightforward. Or I'm going to hit Control-Z to undo that. Or I can delete everything in the column. Now notice if I scroll down, the entire column is selected rather than just the data. I did that by clicking on the top of the column on the letter label, then it selects everything there. If I hit delete, it'll delete everything in the column. Or if I do undo it one more time, I can delete the column altogether and everything will shift back. Notice that this blank moved in this case, but the references are smart enough to know that if they were referencing something that's moved, it will move the reference with them. I'm going to delete that too, just for kicks and giggles. Okay, so we have now done a relatively simple calculation, but notice that all 5 of these samples are actually the same. So if I want to plot this value, I might end up getting 5 results that are all going to fall in the exact same point. We also notice that this is text over here, and that's not going to do us a whole lot of good if we're trying to generate some sort of plot. So I'm going to insert a row, and I'm going to label this as this bracket. It's going to be bracket, and then UO2 plus 2. That's urinal, that's the ion that we're measuring. And so I can say the brackets, which means concentration, we're going to actually write this out so that way we can see what's going on a little bit easier. Again, we've replicated a lot of points. All of these just have our indicator molecule, arsenazo, and then we have a bunch of different data points that are replicated with different concentrations of uranium. So you have 0.5, 0.5, 0.5, 0.5. Now we can click and drag things in order to fill. So all of these are 0.5. If we drag down in the corner, much like we did in the formula, it's going to fill in 0.5. But now if I hit 1 here, notice what happens if I click and drag these. I end up getting 1.5. That's not what we want. It thinks that we're trying to continue on that series. It only works if we have 2 1s in a row and then click those down. Then it realizes that everything else that I'm dragging down needs to be 1. Likewise, 2, 2. Then I could, if I wanted to, drag down for 2. Of course, it's faster just to enter these small amount of data points manually. Okay, so now I'm going to save the document, and I'm going to now generate a curve based on these data points. I'm going to select this column and this column. I'm going to go to Insert, Scatter Plot. This is the preferred way that we like to generate data because the scatter plot doesn't generate lines that aren't there. So we just see the data points. So I'm going to click on this scatter plot without any additional lines. And I notice right away there's a dot that has no business being there. That's that DGA. The DGA is a different type of indicator. It doesn't actually have what we want it to have in it. So I'm going to remove this data point from the selection. So I'm just going to click on the data that was generated in that graph, and it highlights where I had data generated from. And I can move this up and I can move this up, so it no longer includes that data. It's also a great way of dealing with data outside of your linear range of detection. Okay, now if you recall from class, we had talked about how to generate a trend line. We can click on these data points and then right click to add trend line. It's going to draw a line through all those points. That line only does us any good if we display the equation on chart so we can actually see what that relationship is. Ooh. And if we go back, since I clicked out of there, I want to go to trend line options. I want to go to format trend line rather. I also want to display this R² value on the chart. So this calibration is okay. Remember, we really want to have a 0.99 calibration for R². So this really isn't quite where we'd want it to be. So I'm going to quick label this chart so I can see what's going on a little bit better. I'm going to change the layout up here so that we have a title for each axis and a title for the top. That's the ideal for the graph. We don't actually need this series label, but we do want an axis title here. This is going to be the concentration of uranil. That's the name of the ion. And I'm going to put in parentheses, it's in micromolar. Likewise, on this axis title, I'm going to say we have the absorbance, 652 minus absorbance, 800. That way I know from looking at the graph how this data was generated. I also am going to change this, and I'm going to call this a uranil calibration, which is a little bit more descriptive. Looks like my trend line disappeared when I reformatted. Again, it's very easy to fix that. I click on the data, I right click to add trend line, and I want to display the equation R². Nothing's really changed there. One thing that might be important if you are trying to generate a good relationship between your independent variable and your dependent variable is getting more numbers as part of these M and B values. And you can do that by changing the formatting to number and then changing the number of decimal places. So say I want 10 decimal places. Now we can read a lot better data of this calibration curve. It's maybe a little bit more than we need, but we've got a lot more accuracy. Of course, The degree to which this is accurate, again, depends more on the r-squared, but this gives us a more robust idea of what those variables are. You can also use the analysis tool pack like we talked about in class. Again, all this to say our r-squared isn't where we want it to be, but we took a lot of different data points, and we can actually use those average values instead of the independent values to see if we get a better calibration curve. So I'm going to generate an average value for each of these 652 minus 800s that go with these data points. So I want to say I want an average value, and I'm going to label this column as average. Now at the top of each section of data points, I'm going to generate an average. Now I could say I want to equal this cell plus this cell plus this cell plus this cell plus this cell, and then I want to put it all in parentheses because addition is going to happen after multiplication or division, and then divide by 5. That'll give me an average, but it turns out I can actually do this a lot easier. Excel has a ton of different functions, one of which is just an average. So I'm going to type average, I'm going to type parentheses, and now it's going to ask me to enter every number I want averaged. I'm going to highlight these cells that I want averaged. Notice that it labels E2 colon E6. The colon indicates it's a range of cells from E2 to E6. Then I'm going to close the parentheses and hit enter. And notice I get the exact same average value. One of the really cool things about Excel is that we can generate a lot of different functions, and all of those are controlled by the function bar up here. We hit this fx, it tells us that we can insert a function, and we can look for whatever type of function we want. So I could say, I want a function that gives me an average. And it will search through things that it thinks are related to what you want to do. Turns out average is the function that we want. If I wanted, say, the standard deviation, notice there are a lot of different versions of standard deviation that are given. We could also do, let's see, maybe the square root. It's a little bit hard to find a square root button on your keyboard, but we can do it with Excel. Or if we want to report back the number of pi, we can actually use a pi function to generate pi. So notice it gives us information about exactly what it's going to do. You can generate help on any function that you want as well. Okay, so I'm going to now fill in these other blanks, say equals average of these cells equals average of these cells equals average of these cells and equals average of these cells and two more. So now we can try to plot these relative to each other again. I'm going to use these two different columns. I selected these two columns simultaneously by first clicking on this column and then hitting the control button and then clicking on this column. By clicking the control button, you're able to make two selections that have spaces in between them. It's a nice trick. I'm going to go to Insert, and over here to Charts, insert a scatter plot once again. And now I'm going to change the layout to match the layout from before. I'm going to say urinal concentration or calibration. And then give the axes appropriate titles. Average response. It's not completely completely descriptive, but gets us close enough, and urinal concentration in micromolar. Okay. Notice now when I generate the best fit curve, because I took the average of this data, I'm going to end up with a different equation in R squared value. My R squared has actually improved significantly. So that is one way that we're able to deal with data. Now, interestingly, if we have done all this data, we don't see any of the formulas if we were wanting to print this out, which can be kind of confusing. I'm going to save this a second so we could print it out later if we wanted. Now, if I want to print out this and see the formulas, I have to change it so the formulas are shown instead of the results. There's a slick way to do that. We can say control and then we hit the kind of backwards single quotation or backwards apostrophe that's got the tilde on it right under the escape button. So we're going to do that. And when we do that, it tells us all the things that we entered into every one of these cells. So we have the C2 minus D2, we have the average, and it also expands these. So we might need to reformat them before we print, but we can actually see each of the report outs. Your text talks about documenting by writing down every single formula that you did as a text. That's not a good idea. It's a much better idea to just print out a separate sheet like this that has all of these displayed. It'll take you a lot less time. Hopefully this gives you a little bit of an idea of some of the functions we use Excel for. By no means is this video exhaustive, but hopefully it helped.